So this is a quick video to take a look at this, what I believe to be new old stock transformer. I went to I'll call it a yard sale for lack of a better term. There was an ad on Craigslist. Somebody was giving away a large amount of vintage electronics. I went ahead and went down with a friend. She picked up some World War II vintage radios. There was a little bit later vintage radios, almost all of it tube stuff. There was some oscilloscopes. There was just a ton of stuff. He was cleaning out his shop space, and before it went to the dumpster, he wanted to give as much away as he could, and a large amount of it went. I picked up a few things that we'll look at in a future video. Picked up a lot of new old stock stuff, and one of the things was this transformer we see here. It's a Pico, seems to be the name on it. The date looks like June 1958. I believe it's never been used. I mean, basically, looking at the lugs, there is a bit of solder on a couple of them, so maybe it did see some service. It's hard to say. It may just be the tinning. On the bottom here, I don't know how well you can see it, are these large drops. Somebody that came said, well, that transformer's been way overheated and it's melted and blah blah blah. And I actually think that these drips are from when it was, after it was manufactured, it was dropped down into a shellac or some kind of a binding fluid that then hardens up and holds everything together very solid. The the windings and the frame and everything. And I think that's just where it was set down and those dripped down and hardened. The first thing I'm going to do is just take some basic resistance measurements. What I don't know is if are these two terminals primary and this is just a bunch of taps, or is this meant to be the secondary and these are tapped to be like 100 volts, 105, 120, etc., etc., for selecting different input voltages. I'm hoping with some resistance measurements across various terminals I can start to get an idea of those windings. I've got my voltmeter or my ohm meter set up here. Let me get it in ohms. I know you can't see it on screen. Let me get it to 4 terminal. Where's the 2 wire? Where's the button for 4 wire? Oh, I love it when you can't find what you're looking for. There's 4 wire. I have to hit the ohms function twice. Let me go ahead and zero this out. I'm using a set of Kelvin probes here, and this is it's a Rigol 305080. It's a pretty high resolution ohm meter, and I am seeing 12.83 ohms across the primary. I should see an open, which tells me the primary and secondary aren't shorted together. Interesting. I'm not seeing continuity there at all. It may be a range issue. So from, I think this terminal is labeled from 3 to this terminal is measuring out at 0.02 ohms. 0.045 ohms. And we jump to overload. Oh, that's interesting. What we may be seeing is 2 center tapped secondaries here. So let's come around this way. I'm seeing, again, 0.25 ohms. Wrote in the wrong spot here on my notepad. 0.25 ohms from what I'm going to call terminal 4. .47 ohms in that case, which is pretty much a mirror image of what we saw before. If I go across these two, I must not have got a good connection there. So 0.25 ohms. So it's 25 milliohms. Yeah, 25 milliohms between these two taps. between these two taps, and between these two taps, and between these two taps. So just based on what I'm seeing here at this point, I can tell. Let me bring in what I drew up here. Is we have the primary 12.83 ohms. This to me is obviously the primary. It's actually wound not the way I initially drew it here. There is no connection here. So there's a center tapped secondary winding. We know that by the resistance. It's a fairly balanced. It's 0.02 something ohms here and 0.04 something ohms here. So I'm saying, that might be a 9 volt, an 18 volt center tap, something like that. I saw the same basic resistance between the terminals down here, and when I looked from this set of terminals to this set, it was open. So just based on what I see there, I can tell that this is a double. The secondary has a double winding. They're both center tapped. This has got to be the primary. So I guess the next thing I will do is drop line voltage in on this side and measure these secondaries and see what the secondary voltages are. So we'll do that next. So I've got my trusty line cord with alligator clips here. Green is, of course, earth, and hot and neutral. And I'm going to go ahead and hook this up. I don't think I can actually get a good clip onto there that'll stay. I'm probably not going to get a good connection down through any of the other exposed metal here just due to the coating on it. But only reason I'm actually grounding the case is if there was a short from the primary to the body, I'd like it to kick the circuit breaker out. We'll hook onto the primary here. We're hooked up. You've heard me do my little tap test before where I just touch down into the power strip just to make sure smoke and fire don't happen, and they're not. I'm going to leave it hooked up here. And I'm going to go ahead, I've got an AC voltmeter set up. I'll get on the center tap and we'll take a look at both taps. And I'm seeing 1.68 volts. That does not seem very reasonable to me. And 1.68 volts again. Wow, that is really low. So that is on these taps down here. That actually makes me doubt the voltmeter. That's quite interesting. Let's take a look at the other tap. There's no hum here. There's no heat. Doesn't feel like it's doing bad things. I am on volts AC, 1.68 volts again. I'm really not trusting these readings. 1.68 again. Really not trusting these readings. I'm going to go ahead and unplug it. I am on the proper inputs on the meter up to 1000 volts DC, 750 volts AC. I'm going to go ahead and clip onto the primary side and just make sure with it plugged in I'm measuring approximately 120 volts AC, just to be sure. Sorry for the juggling of cords here. This is just kind of a gross test of the voltmeter. 121 volts AC. So boy, this isn't making a lot of sense to me at the moment. Those are heavy windings on that secondary, but I would not say they are. I mean, if we're stepping down, boy, that's a large amount of step down. I mean, that's yeah, I'm not sure. I mean, 3 volt center tapped, are they meant for 3 volt heaters? It's just really surprising to me, as you can obviously tell. Let me go ahead and plug it back in. Actually, let me get a clip from here. There really doesn't make a lot of sense to me. Yeah, 1.68, 1.69 volts. Uh, 0.55 volts. I mean, that's... I should measure nothing over to here. Well, that's interesting. Huh. Confusion continues. I'm really just measuring noise at this point. I'll go ahead and zero it out. So I've zeroed out the meter at this point. Saw the primary wasn't open. These secondaries actually don't seem to be doing anything, which I find a little confusing at the moment. I'm realizing before what I was seeing was just noise to a point. There's 1.68 volts there. I'm not seeing it here. Oh, there it is. So part of what's happening is I'm having a hard time getting through I think the oxide on these terminals. So I'm just going to clean them up a little tiny bit. I think when it was dipped, well, I can see that when it was dipped, it picked up some of the coating that it was dipped in. Just knock a bit of that off of these. Make sure I'm getting clean contact through. Same thing with these guys. Not that I think this is going to affect the outcome, but just so I see a little bit of fresh, shiny. So we did see 120 volts when I measured down there, so that's probably a completely fruitless exercise, but 'tis what it is. I'm seeing with a short 7 millivolts noise with the probes open, just laying here. There's 123 millivolts. Actually, that was 0.7 microvolts noise. It's just okay. There's the 1.68 volts again. I've got a good contact. 1.69 volts. Oops. 1.69. 1.69. And just noise, of course, when I come across to these terminals, because there's no actual connection. They are two independent. So this looks to be a dual 3-volt center tapped transformer. That's kind of amazing. You know, somebody who did old radio stuff, that kind of stuff, might instantly know what this was used for. I guess you could get 6 volts AC out of it if we simply jumpered. I'm assuming these are in phase. We'll find out. That should give me approximately 6 volts. AC, which it does, 6.7 volts. That would be in the range for a filament transformer. So this may have just meant to be a filament transformer for a large number of tubes. That's my guess at this point, what it was probably meant for. It's interesting. I'd hoped the output voltages might be something a little more suited to my needs. Given what this came with, it was boxes and boxes. I should have taken pictures. Boxes and boxes of old radio stuff. Given that's the era this comes from, it's probably meant to be used as a filament transformer. So, I hope you enjoyed this little peek at this little transformer. Maybe you learned something. Hopefully kind of watching me measure resistances, go through it, and kind of determine how it was configured was useful. Our final kind of results here are drawn up here. Primary, 2 approximately 3 volt center tapped outputs. By attaching these 2 points here together on the secondaries, I can get about 6.8 volts AC from terminal 8 to terminal 3. Is what it is. So thanks for watching, and we'll talk soon. Bye.